Do I pick?
Yeah.
Okay. I'd like to pick 39 or 40. You can choose if you want.
39.
Okay, 39. 2x squared minus 12x. 2x squared minus 12x plus y squared plus 6y plus 26 equals 0. And yes, I already know that it cannot be good. It cannot be a parabola. What else it cannot be?
Circle.
Yes. So it can only be it can be a non-conic section, or it can be a hyperbola or an ellipse. Good. How do I start?
Put 26 on the right side. Negative 26.
Yes, you can do that, but I would like to save some time and factor out the 2.
Oh.
And I have x squared minus 6x, and figure out what I need to add and subtract.
36.
It's negative 6 divided by 2.
Oh, sorry. 3.
9 and minus 9 plus. This is okay. So it's y squared plus 6y. I will add the 9 and I will add the 9. I don't have to do it inside because the leading coefficient is 1.
Yeah.
Here I have to do it inside because the leading coefficient is not 1. So it's plus 9 equals 9 minus 26, negative 17.
Wait. Oh, yeah.
Is it okay?
Yeah.
So for this,
Yeah,
I didn't have to do it inside parentheses because the leading coefficient is 1.
But it's the same.
Yes,
it's
like,
I was getting.
exactly.
It's like there's a million
Adding 9 and
right?
subtracting 9 is
Yeah.
the same thing.
Because it's both 6y.
Yes.
6x and 6y. So
Yeah.
taking the squares both of them.
Yes. Good. So then I have 2. And in brackets, what do I have? And then in parentheses, what do I have? And then negative 17. So what is this? The first one is
X minus 3.
good. And the other one is?
X plus 3.
But y. You're right.
Yeah.
Y plus 3. Good.
Looking at the y side.
That's okay. So 2x minus 3 squared, and this is minus 18 plus y plus 3 squared equals negative 17. Now what?
Add 18 to the right side.
Of course. Yes. So this is x minus 3 squared with 2 in front plus y plus 3 squared equals 1. It's definitely not
Circle.
it cannot be a circle because of the 2, but it's definitely not a
Hyperbola.
correct because everything is positive.
Yeah.
So it's definitely an ellipse, but I have to write it. What is the center? And then my next question would be, is it on the x-axis? Is it vertical or horizontal? It depends on these numbers.
Yeah. So
Since this is bigger,
it's vertical.
it's vertical. Good. So the center is?
Yeah, center is 3 negative.
Very good. So now this is a squared, and this is b squared.
Yeah.
Any questions on this?
No.
Very good. Next question. Other topic.
The top of what?
Any other topic?
Oh, the topic. Can we do a
Yes?
sequence or a series?
Yes. So let's go to chapter 12. Determine whether the infinite geometric series is convergent or divergent. If it is convergent, find its sum. 59 caught my eye.
Which page?
Page 806. 59 on page 806. And we have 3 minus 3 multiplied by 1.1 plus 3 multiplied by 1.1 squared minus 3 multiplied by 1.1 cubed plus 3 dots.
Bigger than 1, right? 1.1.
Absolutely. And what do we say then?
So,
Divergent. Yes. R is negative 1.1, but the absolute value of R is a number greater than or equal to, right? Doesn't matter. Either equal or greater than. It's not strictly less than. Therefore, the geometric series is divergent. We cannot determine its sum. And it's divergent. Very good. Let's look at another. Let's say problem 49. On the same page, 806. We're asked to find the sum from k equals 0 to 10 from 3 raised to 1/2, times 1/2 raised to the kth power. If you have the sigma notation, summation notation of the calculator, use it. If you don't, you can always put in the sum of the sequence. You want me to show the sum of the sequence?
yeah.
Okay, let's do that.
Convert.
Let's do that. I have this here, but I didn't click on it yet. Okay, so let's assume that we don't have the summation notation, the sigma notation. So we go to second and list, go to math, and select 5, and then in parentheses, go back to list, second and list, go to OPS and select 5 again. Oh, so I'm assuming that it's allowing you to do that.
Yeah.
For some reason here it does not. Okay, perfect. And now we have to plug in. I recommend parentheses. Put a parenthesis outside here, just for the calculator. Put a parenthesis. Okay, and then 3. And another parenthesis. 0.5 raised to power x.
Close this parenthesis?
No,
No. Okay.
0.5. Yes, I want to close it. Yes. Yes, and then caret x. Close the parenthesis now, which is this one, or this one, and comma, x, comma, 0, comma, 10, comma, 1. And then close two parentheses, one for the sequence and one for, done?
Yes.
This one?
No, it's this one.
Okay. Thanks. Okay. So what did we get? I didn't complete my work here.
I got 5.997.
Is it? I can complete my work with the summation notation. With math and go up to this. And I have x starting from 0 and it goes up to 10. Careful with parentheses in here. I have to put 3 multiplied by 0.5, close the parenthesis, caret, x, and that's what all we had, correct?
Yeah.
Okay, 3 times 0.5 raised to x and press enter. I got 5.99. You said 4.
I got 5. If I
Oh,
said 4, that
5.
was my mistake.
No, maybe I heard 4. Okay, very good. Did you get this, everyone? No?
Yep.
Joey, did you get this?
No, I'm not entering it right because I can only do the sum of the sequence.
So did you select the sum from that?
Yeah.
So you selected the sum, so the sequence. Yeah, you cannot start with x.
Oh,
So
what's the first part?
okay, yes, so let me write it for you. So here's how we write it with the sum of the sequence, and I'll be very careful because this, and then another parenthesis for this.
Right.
So now, in parentheses, I have to have 3, parentheses again, 0.5, caret x, close the parenthesis. Although it is possible that this is not required. It is possible. Check with or without. Comma x, comma 0, comma 10, comma 1.
Okay.
So
I had these
So-
first two arguments mixed
So
up.
this is the expression. So this may be omitted.
Yeah.
So this is the expression. This is the variable in the expression.
Right.
It starts with 0. It ends with 10. And please do it and add by 1.
In the increment, yeah.
Increment by 1. Increment it. Yeah. Good. Next question. So that was the sum.
If
Yes?
if the k be raised to the power k, if that was also like raised to the power k plus 1, when I'm putting it in the summation sequence, do I have to put another parentheses?
Yes,
in?
mandatory. Because otherwise the calculator will only raise it to x and then will add 1.
Okay.
I don't think we will do it without
Okay.
parentheses. Who knows what it does? I don't know. But in order to be safe,
Put another. Okay.
put parentheses as if, yeah. So here's what I would do. Oh, I don't have that here. So I will put parentheses definitely on that.
Okay.
Good. Next question. Anything else? Determine the common ratio of the 5th term and the nth term of the geometric sequence. 36 caught my eye. So it's 5, comma, 5 raised to c plus 1. Next is 5 raised to 2c plus 1. And then the next one is 5 raised to 3c plus 1. And then comma, dot, dot, dot. So they want common ratio, 5th term and nth term. So they want R, 5th term and nth term. So part A, part B, part C. How do I determine R, or the common ratio?
The fourth divided over the third.
It doesn't matter, whichever, yes. The second divided by, the third divided by the second, or the fourth divided by the third, or the second divided by the first. It doesn't matter.
E plus 1 for the second term.
Say it again.
Is that E plus 1?
This one?
Yeah.
C.
C plus 1.
C plus 1, 2C plus 1, 3C plus 1.
Okay.
Sorry about that. Okay, so which one would you like to divide?
Third for second.
You want this over this. Okay, so 5 raised to 2C plus 1 over 5 raised to C plus 1. Copy the base, subtract the exponents. 2C plus 1 minus C minus 1. We have the same base. Copy the base, that's the rule, right? Copy the base, subtract the exponents. From the power of the power of the numerator, subtract the power of the denominator. 2C minus C is C. Negative 1 with positive 1 go away. So this is 5 raised to C. So that's the common ratio. So that is done. In order to find the fifth term, it's A5. Remember, it's A multiplied by R to the fourth power. The nth term, we're going to come back in a second. The nth term is A multiplied by R to n minus 1. So both of them have 5. This one has 5 to C raised to the fourth power. And this one has 5 to C raised to n minus 1. Is this okay? Is it clear? Okay, so then perform the operations. 4C plus 1. So 5 raised to 4C plus 1. And here, first I have to multiply these two. 5 raised to Cn minus C. And then I have 5 raised to Cn minus C, but plus 1. This is C times n. Let me write it again. It's not clear. Sorry. So 5 raised to Cn minus C plus 1. Good. Next question or topic.
Where's the plus 1 coming from? Oh.
Copy the base, add the exponents.
Oh, yeah.
So this is a kind of a typical type of problem. I don't think you can see that. Okay, in calculus, not in Calc 1, in Calc 2, in which we are asked to determine the area enclosed by the line and the parabola. If I don't know how to graph this, or I don't understand how to graph it or graphing a line, I may not be able to determine the points of intersection, and I may not be able to determine the area. Same thing here. If I don't know how to graph a circle, if I don't know how to graph a parabola, who knows what the question is all about in calculus, I will not be able to proceed or have difficulties. Okay, next topic. Anything else? we summarize the topics that we will have on the final exam, and we reduced everything to 16 topics. So 4 from test 1, 4 from test 2, 4 from test 3, and 4 from test 4. Okay, anything else? Anything else? Exponential log equations.
We'll try one of those.
Okay, which one?
Uh,
Log? Okay, so let's look at the end of chapter 4. And that is on page.
That's a paper.
Say it again. Yeah. 1, 2. Good. Sure. Okay, on page 368, problem 10. Please choose A or B, or both. Page 368.
Let's do both.
Good. Good pick. So this is problem 10. 368. So log base 2 of x plus log base 2 of x minus 2 equals 3. Like before with the trig equation, what is the first thing I have to do? Don't do anything. Just look at it. Identify what it is, and then ask yourselves, okay, are there restrictions needed here?
Yep.
Yes, because log is not a function with, is not a friendly function. It's a function with restrictions, like tangent, cotangent, like square root, like rational functions. So I have to state or find the common domain first. Now you can say, no, I don't want to find the common domain, but I promise I will go back and check. You may forget. I think I've seen it in your tests.
Yeah.
So be very careful every time you're given an equation. First, the first question that comes to mind is, what is it? Secondly, do I have to state restrictions? Right? After I identify it correctly, I should go to that step. Restrictions or not. Yes, it happens that I have to write a common domain here. This one, we know it has to be greater than 0, and this is x minus 2 greater than 0, and I know that the common domain must be, I can picture this in my head already.
X is greater than each one.
Yes, common domain is 2 to infinity. If I get solutions that are not in the common domain, then I'll have to exclude them, because one or the other or both will not exist. Only now I'm allowed to condense. Notice that restrictions are always stated on the row equation.
Yeah.
If you condense it, the domain will be different.
Yeah.
So be very careful. Restrictions are stated on the row equation. And now I can convert it. Log base 2 of, yes? Yes.
Square minus 2x.
Yes, so this is x squared minus 2x indeed. And now I have to be very careful how I change this, because I have to change it from a log equation into an exponential one.
Right.
How do I do that?
X squared minus 2x equals 2 to the third.
Right, 2 to the third equals x squared minus 2x, and you are correct. X squared minus 2x minus 8 equals 0. Because now, in the next step, I try to identify it again, and I see it's quadratic, and I have to set it equal to 0. If it takes more than a blink to factor, move to the quadratic formula. Don't waste your time.
It goes with x minus 4 and x plus.
Right, right. So there are two options. And you can say not so fast.
Not so fast.
Exactly. So this is not an option. The only one is this. Very good. Now you can teach this class. I want to make a little video for my summer classes and for my fall classes and so on and so forth. And if you are interested, like a 5-minute conversation among you guys saying how you studied for this class or any math class, and how you know, you have to keep at it and how you have to blah blah blah. So if you want, like, we can meet after, you know, sometime next week if you want. Like, it's not a requirement. It's not. You may say, I don't want to be presented to your other students, but I like to have like a 2 or 3 minute, just whatever you want to say, and how you worked on, and how you know, in the beginning it was slow and you had some difficulties with understanding or maybe following and so on and so forth, but then things started clicking. And if you want to just make a little speech or, you know, 2 sentences, 1 paragraph if you want. It would really help me, and I will show this to my students, because here's why. If I come in like, you know, like an authority here and I tell them something, you know, but if it comes from you to another student, it may be a totally different perspective. It may be a different, you know, they may say, oh, okay, I have to be serious in this class. So think about it. Okay, the second equation here is 2e to 3x minus 11e to 2x plus 10e to x plus 8 equals 0. So first thing, what would you say about this function? I'm sorry, this equation. You will immediately say it's definitely exponential.
Yeah.
You will first have to say that it's exponential, because the variable is only at the exponent level, so it has to be exponential. There is nothing else. Okay. Second thing that I observe here is that I see 4 terms.
Yeah.
What does 4 term mean? Always. How do I handle 4 terms? Forget about this equation. When I have 4 terms, how do I handle 4 terms? Always. By
Grouping.
exactly. Absolutely. I see 4 terms. My thought is always to factor by grouping, if it's possible. I don't know. Okay. Now I see the 2 and I see the negative 11, I see the 10 and I see the 8. So obviously,
yeah,
it may work, but it's not obvious. Okay. So the next thing that I would do is I will say, yeah, this e to the x bothers me. So I'm going to say let t be e to the x.
Okay.
And then I have 2 t to the third, I hope you agree, minus 11t squared plus 10t plus 8 equals 0. E to the x can wait for me. Now, there is something we discussed. It was optional. I did present it, but I'm not going to test it. We said this. If I cannot factor, and if there is no formula that I can use, like the quadratic formula doesn't work for anything else but quadratic equations, and it's not quadratic. My other possibility is, there are very few possibilities here. One possibility is to punch in the calculator and find 3 solutions for t. I'm hoping that it works. But the other option is the rational zeros. If this polynomial has rational zeros, that they must be among 8 divided by 2, the divisors of 8, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and the divisors of 2, plus or minus 1, plus or minus 2. So I will punch in the calculator 1 with positive and negative, 1/2 with positive and negative, 2 with positive and negative, not again 1 because I already have it, 4 with positive or negative, 2, I don't need to do it again. 8 with positive and negative. And 4, I don't need to do it again. So I will put this in the graphing calculator in y equals and see. So I have 2t cubed, 2x cubed, and then minus 11 x squared. Oh, of course, I always do that with the software. Sorry about that. 2x to the third. Okay, minus 11 x squared. And then what else? Plus 10x plus 8. Plus 10x plus 8. Okay, so I go to second and table. Oh, yes, of course, I forgot. I have to change that again. And now second and table, and I have 1. I have -1. When do I stop? When I get how many at the maximum?
3.
Oh, of course. Okay, -1. Okay, 2. I got 1. That's all I really need because I can use a synthetic division and find the quotient. Okay, -2, 4. I got the second one. -4, 8, -8. And there is also 1/2, right? 0.5 and -0.5. So I got 3 solutions. 3 solutions for e to the x, actually. So then I'll say e to the x, because that's our t, equals 2. E to the x equals 4. And e to the x equals -0.5. Okay. Obviously, this is impossible for e to the x. If you remember, the graph of e to the x is this. The graph of -0.5 is this. Y equals -0.5. They will never meet. So this equation has no solutions. The other two, x equals natural log 2 and x equals natural log 4. Because of course I have to apply natural log to both sides.
Yeah.
So that's how we handle polynomials. Or I graph it and try to find the zeros. Or the x-intercepts. Now, let me see if I have my, I don't know if I showed you this. The calculator that I like is this one. It's a very old calculator. It's an 86. I don't know why they don't make them anymore. And here is a great, great feature of this calculator. It's called poly. Poly. So second and poly. And it's degree 3. And I put in the coefficients. So the coefficients were 2, -11, 10, and 8. So once I put in the coefficients, then I press this button that says solve.
Well, that's nice.
And I get 4, 2, and -0.5. But I don't understand why they did not transfer this feature to all the other calculators. Very good. Anything else?